Hi, my name is Carl Schroff.
My name is Nolan Cook.
I'm Anna Russell.
And my name is Will Holbrook. And this 2023 season for FED, we did the Nuclear Power Probe. To better understand a project, you have to understand what we're actually measuring. So what is Cherenkov radiation? This occurs when beta particles travel faster in water than light can. And this excites the surrounding water particles. So, as water de-energizes to its normal state, photons are released corresponding to blue and ultraviolet wavelengths, which is Cherenkov radiation. The radiation can be seen as a blue light within the pool of the nuclear reactor.
In order to design the most accurate probe possible, we researched different types of light-sensing diodes and found the most effective diode for our application was a silicone photodiode. We also researched suitable wire and sealants that are suitable for use in a reactor pool, and we decided on 18-gauge SJ00W power cable and JB water weld epoxy. We explored possible failure points and inconsistencies to design the probe in a way that we can account for many possible cases such as light deflection, waterproofing, dark current, and wire resistance. We tested the integrity and precision of the probe at every step of assembly as well.
Research and decided what materials we needed for our design. We had to obtain them. We went to multiple Lowe's and hardware stores to obtain our PVC pipe and wire. Then we had to plan times around campus that we could actually put it together, such as the engineering design place. There we were able to use power tools and start building our power probe. In order that we didn't fall behind, we created a detailed timeline to mark for each week to figure out what we would have done by that day. It worked very well because we were never rushed for time and we were ready with our FED project about 2 weeks prior to FED Day. We also all contributed a design sketch at the very beginning of the semester of what we thought the nuclear power probe. Then we narrowed it down to one specific detailed design drawing at the very end, before we started putting our design in CAD. The CAD drawings were really tough for our group because none of us had ever used it before, so we spent many hours trying to figure out, looking up videos to try and make this one PVC pipe with different parts to demonstrate our nuclear power probe.
To begin assembling our probe, we cleaned out our components. Prior to sealing the probe, we dry fitted our joints and ensured the electronics were functional. When we were ready to seal the probe, we primed interior and exterior mating surfaces and applied JB water weld to the inside and outside of all joints. This acted as 2 seals for every joint in case one of the seals were to fail. In addition, we also drilled an offset diameter hole into the front end cap to act as an inset shelf for the plexiglass window in case the probe was dropped. We wired 3 photodiodes in series and mounted them on a black ABS plastic backing plate. Connections were heat shrunk and taped to act as an extra line of defense to water and accidental connection failures. While wiring, we noticed that if one of the diodes were to fail in series, the entire circuit would fail. So to account for this, a backup circuit was wired into the series circuit to redirect the current should one of the diodes or connections fail. We made sure to account for as many possibilities to ensure our design was robust, reliable, and accurate.
Finally, with our design complete, we were able to test our power probe in the Polestar nuclear reactor here on campus.
When we arrived at the reactor, the staff there gave us 4 known power levels and allowed us to take data measurements at each one of those levels. The levels were 0 kilowatt hours, 100 kilowatts, 500 kilowatts, and 900 kilowatts. From the data we collected, we created a line of best fit in Excel and were able to find a function of the line of best fit with which we could calculate an estimated power level.
Surprisingly, when we measured up the voltage from the reading of our multimeter to the nuclear power level, it graphed out to be a mostly linear line, both with and without the unknown value.
By using the 4 known power levels that are given to us at the test day, we were able to create a graph and extrapolate the data from this graph to figure out our mystery power level. By doing this, we were able to find the mystery power level to be approximately 686 kilowatts, which was very close to the real level at 690 kilowatts. We calculated our percent error and ended up being 0.49%, which was very close.
Due to the percent error and our integrity in our design, we actually won Fed Day.
After finishing testing, we analyzed our data to seek inaccuracies in our project and to see if there was anything that we could improve on for the future. We broke the coupler joints in the epoxy wire anchor after we tested to see if there was any leaks or damage inside of the tube, and luckily we did not find any water or any damage. However, possible improvements that we could have on this project would be a lens to decrease the focal radius of an incident light. This would be done by having a concave plexiglass cap put on the end, and this would reduce dispersion and inaccuracies. We could also have a matte black interior on the end cap, which would help absorb extra light that got in but did not hit a diode. Instead of having two 5-foot poles, we could just have one 10-foot pole, which would mitigate the failure of a joint in the middle. We could also have a larger diode array with more diodes on the end cap in order to increase the accuracy of our light detection. For our future engineers who will be completing this project next year, we've come up with some advice to help you through your first engineering project. First, make sure to start early and give yourself plenty of time on all of the milestones. This will help you have more time to create, brainstorm, and design your project. Also, learn how to solder and use other power tools before the project. That way, whenever you end up building your project, you'll know how to use it and you'll be more accurate. Also, learn CAD for accurate drawings. A CAD drawing is required for this project, so make sure someone in your group knows how to use this. Make sure to do your homework on your supplies and research everything to guarantee that you'll have the best results come test day. And most importantly, make sure to have fun. And go Pack!
Thank you for watching our presentation. We all had fun designing and making our project. And go Pack, baby!